Hello and welcome to this video. In this video, we will start discussing sorting algorithms. So let's get started with this. So uh, typically in your college, when you study data structure algorithms or otherwise when you work, you will need to sort values. Uh, so by sorting, we mean that arranging a list of values in increasing or decreasing order. So sorting is the process of arranging a list of values in increasing or decreasing order. Now there are various algorithms in sorting. Typically in college you will study bubble sort, insertion sort, selection sort, merge sort, quick sort. So those are the basic algorithms of sorting. Now some of these algorithms do not require extra space in the sense they don't need extra memory to sort the sequence or the list or array. When such is the case, then these algorithms are called in-place sorting algorithms. Some algorithms like merge sort or polyphase cascaded merge sort, those require extra space for sorting the list. So those are not called in-place sorting algorithm. Then the second term is internal or external sorting. When the data to be sorted is kept in memory altogether, then the sorting is called internal sorting. That is, it does not make use of disk space. Earlier, when there was not enough RAM in systems, people used to do external sorting by using a part of array on disk, then sort part of array in memory, then you read another part in memory, you sort them, then you sort another part, and finally you merge that. So those are merge sort variants. Nowadays, usually we don't concern ourselves with external sorting while working in professional environment. External sorting is interesting from academic point of view, but there is very little use of it in practical life. So those which make use of disk are called external sorting algorithms. Now there is also something called stability of sorting algorithm. So by this we mean that I'll give you an example to understand what I mean by stability of sorting algorithm. Suppose there is a class in which there are 40 students and they have got marks in certain paper, say maths or computer science. Now the marks can repeat and the names can also repeat when we particularly talk of first names only. So there may be more than one student with the same name, and there may be more than one student with the same marks. So when you perform sort on marks, then the original order of names might not appear. If you sort on names, then the original order of marks may not appear in the final result. So such algorithms where the original or the relative order of input is not preserved are called unstable algorithms. Now, some algorithms preserve the relative order. They are called stable algorithms. All algorithms can be made stable by means of re-implementing the comparison function. So you can assume that almost all algorithms are stable if you write the comparison algorithms carefully. Now, one more point is mechanism of sorting. So there are typically three ways of sorting mechanisms. One is by exchange, one is by insertion, and then the third one is by selection. We will see them one by one. Bubble sort is by exchange. Insertion sort, as the name implies, is by insertion, and selection sort, like its name implies, is by selection. Then there are other techniques like enumeration and special purpose sorting. Some sorting algorithms are hybrid algorithms. For example, C++, STL, or Python sort algorithm, those are hybrid algorithms. So they make use of two different algorithms to sort the input sequence. So we will study those advanced sorting algorithms later on. So to begin with, I will discuss five algorithms: bubble sort, insertion sort, selection sort, uh, then quick sort and merge sort. Then I will discuss heap sort once we have studied the trees, binary trees. After that, we will study heap sort. And other sorting algorithms like Kim sort or Labradorite sort, those algorithms we'll study later on as uh, we discuss complex algorithms. So let's get started with the algorithm or implementation of bubble sort. So this is my main program. As always, I have split this into three parts. One is the header file, which has the function bubble sort, which implements bubble sort. It takes an array or pointer. I have denoted as a pointer because arrays when passed degrade as a pointer. And then we have n. This should be size underscore t. This is the size of array or pointer here. Now in main, if you see, we have pre-declared an array and we found its length, and then we pass it to bubble sort, and then after that we print the sorted array. This is the print function, so there is nothing special about it. So those are driver programs and header files. The reason of splitting I have described in earlier videos is we want to make use of these as a library, so that when we later need to make use of bubble sort, then we can simply call this. Now let's look at the implementation. To begin with, I will want you not to focus on flag false. Don't read this, ignore it, because without this also the algorithm will work. Now to explain this, let me write out some values: 2 and then 4 and then probably 3, and let's put 6 here. 5 will also work, 6. Okay. So consider an array which has 4 elements, 6, 2, 4, 3. Now this array arrives here and its size is also here. We have two loop variables I and j. So we start with I is equal to 0. So that means this is what I is. And then we take j is equal to 0, j less than n minus I minus 1, and j plus plus. You can instead make it j is equal to I. Okay. If you do that, then you should rather, let's not complicate it. Let's keep it j is equal to 0. Now what we do is we compare aj with aj plus 1. Okay, so j is n minus I minus 1. So n is given, I is 0, okay, and minus 1 will remain. That means in this case n will be 4. So j is here. Okay, sorry, j is compared with this. J is also here. J is here. So now we compare aj and aj plus 1. Okay, so what we do is here, this is j plus 1. So we check if aj is greater than aj plus 1. So 6 is greater than 2, which is true, so we will swap. So this is the simple swap function which we have. So now you see that this condition is satisfied, so values will be swapped. Okay. So now our array will be 2, 6, 4, 3. After that, j will advance, and this will be j now, and j plus 1. Again, it will see that 6 is greater than 4, so it will swap, and it will again swap. So this is how the first iteration will look like. So in a sense, what happens is that the greatest element, whichever it will be, will reach final position. Okay, all right. In first iteration, one element will reach the bottom of the bubble sort. Now in the second iteration, what will happen is this, you also notice that 2 has reached the top. In the second iteration, what will happen is, this is where I will start, and j will again start from here, and this will be j plus 1. Okay, but j will go only up to here, that is n minus 2. All right, this is n minus 1. So in the second iteration, since we know that we have put 6 in its proper place, we don't need to sort it. So it will go up to here. So in this case, it will see is 2 is not greater than 4, so that will remain. Then j will move to this, and this will become j plus 1. So you see 4 is greater than 3, and then 3 will be here and 4 will be here. So at this moment, our array is sorted. Okay, so it will keep doing the same thing, but this condition will no longer be satisfied. Once the array is fully sorted, this condition will no longer be satisfied. Now we come to the last part, that is what I said, that you don't pay attention to flag. Now we come to flag's importance. Now once the array is sorted, okay, there will be no more swap. So we don't want to continue after that. That is why we have this flag to indicate that swap has happened. So it has been initialized with false, then we assign it false before the inner loop. Now if a swap occurs, we make it true. And then we, at the end of the inner loop, we check if the flag is still false, we break out of outer loop. At this moment, if this is true, if the flag is false here, that means no swap has happened. That means the array is sorted. For example, the input may be sorted. So if it is already sorted, what is the point of running n square times? Because this is n times and this is n times. So on average, it would be n square. That we will come how it is n square. So if the array is already sorted, we don't need to sort it. So the best case what you call complexity would be order n. But without this flag, the best case complexity won't be order n, it will be n square. So just to improve the runtime in case array is already sorted, we use this flag and then we sort this. Okay, that's it. So we have seen this in action. Now let's see this. We try to run this. So we compile this. Our compilation flags are val, w error, pedantic, std is equal to C11. That means we capture all the warnings, treat them as error. Pedantic means it should be compliant with ISO for standard, and the ISO standard which we choose is C11. So it has been compiled, and now let's see the output. You see the sorted array is in correct order. We have proper elements at their proper positions. Now with this, we come to the end of the implementation part. Next part is algorithm complexity. So bubble sort on, in worst case is n square, in average case is m square, and is in best case is on. Now how do we arrive at these values? I'm not going to repeat this. There is very good work done by Dr. Donald Knuth. So this is the analysis of bubble sort. It is volume 3, sorting and searching of the art of computer programming. I'll strongly recommend you to buy the hard copies. I have actually, I bought them multiple times and gave it as gift. So I have a hard copy of all 4 volumes which have been published. So the analysis of bubble sort will give you the details, how it has come. And here you can see that minimum case is order n. So you can see here. And then in the average case, it would be n square. And in the worst case, it is n square. So you see that it can be quite complex to deal with such math. That's why I will avoid computing the complexity. If you are interested in exact computation, then I will implore you to read Dr. Knuth's book. It has very good mathematical analysis of almost all the algorithms which we are going to deal with. So with this, we come to the end of bubble sort. In the next video, we will study insertion sort and we'll see how to implement sorting by insertion. But insertion sort is also inefficient. Bubble sort is quite inefficient actually. People don't use bubble sort or insertion sort in practical situations. Most used sorting algorithm is quicksort, and that would be the fourth algorithm, sorting algorithm, which we will discuss. With this, I come to the end of this discussion on sorting, and in my next video, I will see you with insertion sort. Thanks a lot for watching. And by the way, if you have liked this video, please subscribe to the channel and like the video. If you have a question or you want to ask to me to make some videos on certain topics, let me know in the comments. And do not forget to like the video because that will help it reach many other students like you. So with that, I'll say goodbye. See you in the next video. Thanks a lot for watching. Happy programming.